volume lesson 6 from module 5, and it's our homework. We're finding the total volume of rectangular prisms that are put together or composite. So in number 1A, I see that I have 2 rectangular prisms in my structure. So I'm going to break it apart into 2. There's 1. Here's a second rectangular prism. What I'm going to have to do is find the volume of both A and the volume for B. So let's see what the length for each structure is. I see a 13 here, and although there are no arrows, I could see that the length of prism A is 13 inches. The length of B is also relatively clear as 5 inches. Now I'm going to find the width for both prisms. The width goes back. I don't see the width for structure A, but I do see that it's the same width. It appears to be the same width as structure B. Structure B has a width of 2 inches, so that is the same for structure A. Finally, the height for both structures. The height I can clearly see here for structure A is 2 inches. Now, the height for B, I have to do a little bit more work. It doesn't show it anywhere specifically. I see that the entire height of the structure is 4 inches. And if the height of A is 2, then I can subtract 4, the total, minus 2 for A. 4 minus 2 would give me 2 inches for a height of prism B. Okay, now I can group them any way I want. I'm going to group length times width. (26 times 2). 26 times 2 is 52 inches cubed. That's the volume of structure A. The volume of structure B, length times width, my base area would be 10 times 2 is 20 inches cubed. Now I have to put together the volume of A and the volume of B to get the total volume. 52 plus 20 is 72 inches cubed. Final answer. Here's my solution strategy. I say I broke the structure into 2 rectangular prisms, A and B, and I found the volume of each prism separately and then added the volumes together to get a total. My only difficulty was determining the height for prism B. I needed to subtract the height of prism A, 2 centimeters, from the total height of the structure, 4 centimeters, to get 2 centimeters for the height of prism B. Okay. Question B. Again, I see 2 different prisms in my structure. I see an A prism and a B prism, similar to question 1A. I'm going to find a volume of A and a volume for B. Now let's just plug in the numbers. Let's find the length for each. It looks looks clear that 18 centimeters is your length of A. It looks clear that 21 is your length of B. I'm now going to find the width. Okay. The width of A appears to be right here. The width of B looks like it's shown on the other side of B. It looks to be 7 centimeters. Now, just find the height. The height for A, I see is 2 centimeters. The height for B is shown on the other side, 9 centimeters. Okay, now I can group any way I wish. I'm going to group my length and width together for this. And 18 times 3 is 54. Need to do an algorithm. Do it on the side. 18 times 3 is 54. 54 times 2 is 108 centimeters cubed. The volume of A is 108 centimeters cubed. For volume B, I'm going to put my length and width together. 21 times 7 is 147. Do an algorithm, quickly do a side algorithm. Multiply that by my height of 9. 147 times 9. 1,323 cubic centimeters. Now I have to put the two together, 108 and 1,323, to get a total of 1,431 cubic centimeters. Now if we wanted to go a little advanced, but it doesn't ask us to, we could see that that would also be equivalent to 1,431 milliliters, which would be close to 1.5 liters. That's just a little advanced thinking, not something we need to think about for this particular question. My solution strategy is I broke the structure into two rectangular prisms, A and B. I found the volume of each prism separately and then added the volumes together to get a total. The length, width, and height for each prism were clear. Okay, letter C. We have something unique here. Our first structure that has 3 rectangular prisms in it. So I'm going to have to get the volume of A, a volume for B, and a volume for C. Alright, let's try to figure this out. When I was solving this problem, there's some information that is a little unclear. This is the most unclear problem on the homework, I believe. So let's try to work our way through it. Let's get a length for each. Let's get a length for A. Pretty clear that the length for A is 6 millimeters. The length of B is unclear. I don't know if that 20 means the entire length or just this. The question was not properly constructed, but for this particular question I'm going to assume that it means the entire length. Very unclear, and I apologize. The length of C is clear, 3 millimeters. Okay, now I'm going to go to the width of each structure. The width of each structure looks to be the same. A, B, and C all have the same width. I don't see the width in A and B, But C is clear at 3 millimeters. And if it looks like they're all the exact same, I have 3 millimeters as my width. Finally, my height for each is clearly listed. 4 for structure A, 13 for structure B, although it's not drawn to scale because the 13 does not look taller than the 5 that we're given here in structure C. So again, poorly constructed question, but we'll solve it the way it is. All right, so now we got to find the volume of each. I'm going to put together my width and height because to me that's going to appear to be easier because I can do 6 times 12, 72 millimeters cubed easily. Then I'm going to take, you don't have to do it in this order, but I did. 13 times 3 is 39 times 20. 2 times 39 is 78. The 0 is 780 millimeters cubed. And I'll do length times width. Base area for this is 9 times 5 is 45 millimeters cubed. So I would have to put all 3 together. 72 plus 780 plus 45 to get a total of 897 cubic millimeters. My solution strategy is down below. I broke the structure into 3 rectangular prisms, A, B, and C. I found the volume of each prism separately and then added the volumes together to get a total. My only difficulty was determining the length for prism B. It was not clear whether 20 millimeters was the entire length of B or just part of the length. I used 20 millimeters as the entire length. Okay, and last one for question 1. D. Hopefully this is a little more clear than C was. We have 2 rectangular prisms, A and B. So we're going to find the volume of A. And this repetition is important. It just gets me in the correct mindset. I know some people like to skip these steps, but the repetition really helps. Let's find the length of both structures. The length of A, I like the arrows there, that's more clear than question C, is 12. The length of B, although there are no arrows that show us, is also relatively clear at 10 meters. The width of A, I like how the arrows go back, 4 meters. The width of B, 2 meters. The height of A, 9 meters. And the height of B is a little bit unclear, but I can solve it. The entire height of the structure is 15. We've figured out that the height of A is 9. So the difference between the total structure and A will give us the height of B. So 15 minus 9 gives us 6 for the height of structure B. Okay, then I can solve for each volume. 12 times 4 is 48 times 9. Do the standard algorithm on the side. 48 times 9, 72, 36, 432 cubic meters. Volume of B, a little easier. Height times width is 20 times 6 is 120 meters cubed. Put them together. 432 plus my 100 20 is 552 cubic meters. Final answer.